Hi everyone. Today I'll do a demo on schematic design using Xilinx design suite. So first you need to install Xilinx in your system. I have a Xilinx ISC design suite 12.4 version here. If you have some other version you can also use that one also. So to press OK. So by default it will give you the last project which you have designed here. So go to file, then go to new project, then give a name to the project. Say I want to simulate an OR gate, so I'll give the name OR gate. So after that you have to give the location where you want to make the project. So beware that here in the name you need not to give any keyword. Like if I mention OR, then it is a keyword in this Xilinx. OR as an OR gate is a key, OR is a keyword. So you should specify some other name here. So I am giving the name as OR gate. Then in the location, if it gives some problem, like if sometimes in C location it gives some problem, you should change. Then you should change the location to be E or something else. Then you have to specify the top level source type. So the top level source type here, since we are designing the schematic, so you should select the schematic. In other case, if you want to program like in VHDL or in Verilog, then you should select HDL. So right now I am selecting schematic, then you have to select next. So this new project wizard will open. In this new project wizard you have to mention the family, the device and the package of the FPGA which you will be using to burn the program. So in this video I'm not demonstrating how to burn or program the FPGA using this code, but for the timing you should, if you have an FPGA, then you should select the family of the FPGA here, and over it the device and the package will be mentioned. You should select that one here. So what I have an FPGA is in Spartan 6 with this device and this package. So after that you have to select the simulator. So by default we have an ICF simulator with this, so you should choose that one. Otherwise if you want to do it in model sim and you have installed that, then you can select from here some other model sim version. So you have to select iSim simulator I am doing with. So then you have to press next, then finish. So after that you have to select create a new source basically. So here is an option of new source, or you can also go to project and select new source. It will ask you whether you want to create a schematic, you want to create a Verilog module, you want to create a VHDL module. So I'll select schematic here and give a name to the file, say OR gate, then select, and here you have to tick add to project, press next, then finish. Okay, so after that you have to, in this window will open, here you have to create your schematic. So here you can see is an option of add symbol. You can select here, or you can directly go to symbols here and select the gate which you want. Like I want to create OR gate, so I can just simply click O in my keyboard and go to OR. Now here it is. So there are different OR gates available, OR2, OR3. So OR2 means it has 2 inputs, OR3 means it has 3 inputs. It is a 3 input OR gate. So we will be going with OR2 gate. You select it and left click on the screen here, then it will be placed. Then you need to cancel this option. For it you can press escape button, or you can directly go here in this arrow, and that is the select cursor. Then we need to place other gates here. So like if you want to create some big combination or any sequential design, then you can place your group of gates here and then connect them using wire. Like here you have an option of add wire. You can select add wire, and like right now it is not seeing, so we can zoom it from here. You can go to plus, then zoom in multiple times, so it is visible now. So you can go to wire, add wire, or you can also go to add and select wire. So here you can simply select wire and then go to the input port left mouse click, then again left mouse click. Then to the other port you can select left mouse click, and again double left mouse click to stop this or cancel this selection. Similarly to the output. So this is wire is needed basically when you are connecting multiple gates and you are connecting one port to the other at that time. So right now I don't need it, so I can also delete it this one. So then I can select add IO markers, or you can also go here add and add IO markers. These are the input and output ports which we will be mentioning here. Like I can select here the left mouse click, it will show me an input port, again the left mouse click, and here also left mouse click. So I have placed the input and output markers, then press escape. Now I can double click here to see that this it will automatically take it as input. Again here it is automatically taking it as input, and this one it is automatically taking it as output, since I have only made one gate. If you are making a group of gates or a combinational circuit, a complex circuit, at that time you may need to mention if it is needed. So you should always check from here that whether it is this port you are specifying it is input or output. Then you can rename here these ports. Go to rename port. You should need to right click the port and then this window will open. Now so I am renaming it to A. Okay. Then again right click here, I'll rename this port to B. Okay. This one I'll gonna rename it to Z or Z. Okay. So A and B are input of my OR gate and Z or Z is my output of the OR gate. I can save it here. So whenever schematic is ready, we have placed our IO ports and renamed them, then we can go further and simulate the design. So we can go here in the design window here and select simulation here, simulation tool. Earlier it was on implementation, now it is on simulation. After that you need to select the OR gate or the SCH file, .sch schematic file. Then you need to go here in the simulate behavioral model and double click here. After a couple of minutes and a few seconds, this iSIM simulator will open. See here, iSIM is written here. So here we can do the simulation of our schematic. So here all the inputs are visible and output. A, B are our inputs and Z is our output. Here you can see I here is written and here O is written. So here we need to give the values, like say I want to simulate my circuit for all the four combinations for this, like 0 0 0 1 1 0 and 1 1. So I will give right click here on the A and select force constant, then force to value 0, then apply OK. Similarly for B, right click, force constant 0, apply and OK. So after that, when I have forced the values to both the inputs, then I need to run my simulation for some specific time. So there are two options, either I can run all here or I can run for the time specified. So run for the time specified is a better option for me, because if I will run all, then it will continuously run, then I will need to manually stop the simulation. So I will run it for a specified time like this. So see here, now all the inputs are set to 0 0 and Z is also 0 for the OR gate. So I can also zoom out here, zoom to full view. I will click here, I will see all the values. Since I need to go for the four combinations, so I will minimize my simulation like this from the minus sign. See here, I can see that for the 1 microsecond, from 1 microsecond to 2 microsecond, only for 1 microsecond my simulation was run. I can also change the time here if I want to run my simulation for some longer time or some less time. So again I will run for 0 1 case, apply, OK. Then I'll again run for the specified time. See here, my B input has changed from 0 to 1 and Z has also changed from 0 to 1. So this is OR gate. If any of the input is 1, then output will be 1. And this is the cursor here. it will show you the values of all the input and outputs at this particular instant of time. Like here in 1.33 microsecond time, my A and B is 0 0 and Z is also 0, and at this instant 2.5 microsecond, my B has gone to 1 and Z has also gone to 1. Similarly, you can run for all the other cases. Like say if I want to force A to 1 and B to 0, then I can run this one. Similarly, you can see for the 1 0 case also the output is 1. Now for the last case, if B is also 1, the 1 1 case, then this is output is also 1. So this is the simulation for an OR gate. Now one more thing, if you are designing a sequential circuit, at that time you will need a clock. So how to give clock here? So see if I can see this A and B, this also seems like an clock. This is a 4 microsecond period clock. If you can see, what I am seeing here, showing here, this one is 2 microsecond period clock. Okay, so what I can do is, for performing these all 4 actions, I can give 2 clocks to A and B. I can give a clock of 4 microsecond to A and 2 microsecond of clock to B. Then I can also get this same thing in one single step, which right now I had to force 4 different values. So how to do that? So for that I need to select here on the A and select force clock. Then I have to give it leading edge value 0, trailing edge value 1, then a period of 4 microsecond. 4 you have to write here 4 US, it means 4 microsecond, then apply, then OK. Similarly for B, force clock, leading value 0, trailing edge value 1, and period of 2 microsecond, then apply and OK. So now I have given a pulse of 4 microsecond here and 2 here. So I can also change the time here from the run time from 1 to 4 microsecond. Then I will select here run for the time specified. So see, from 4 microsecond the simulation has run to 9 microsecond or 8 microsecond, from 5 to 9, sorry. So here all the 4 cases are visible, which earlier we were doing with 4 different force values. Similarly this is the way with which you can give clock to the inputs, and you can check the value at each instant of time by selecting this cursor. So this is it for today. Thank you everyone. If you have any queries, you can post in the comments.